Hello, this is Old Electronics Fan. Thanks for stopping by to view my video. This is what I call the extreme poor man's variac. And as you can see, it's a little crazy. I've seen other people with 3 bulbs on their setup, and what really got me to build this one, actually I built this one and then I saw other people with similar ideas, but what got me to build this one was I saw people swapping bulbs, adding bulbs, and so on. I thought, that's a little bit cumbersome. Maybe I should come up with something that would be a little more convenient. And the other reason for building this at all was because I didn't have a variac, I didn't have an isolation transformer. I was just starting out again in the old vintage electronics hobby, I should say. And I was just starting to put together equipment. I've now gathered a whole bunch more since I built this. But the other reason I did this was because it was really cheap to build. Radio Shack was going out of business. This whole middle section here is all Radio Shack parts, and it was like 50% of what they were normally, or 70%. It was pretty cheap. Then originally I built it on a slab of wood, and I didn't like that. It was too long and cumbersome. So then I went and bought this box at the hardware store and these sockets, and of course I had this already, so I rebuilt it and put everything together this way. I put a little leg behind it so it would stand up, because when I added this to the mix, the kilowatt, it was annoying because I couldn't see what was displaying without sort of sitting up and peering over the top of the thing to see what it was doing. So I added that just to make it easier to use. And actually I was in the process of filming this for the first time, and I started checking some stuff out, and I realized that I had made a major error in my thinking, because I had it in mind that if I wanted 150 watts, or the capability of 150 watts worth of bulbs, I had to put them in series. I did not really understand how bulbs were designed and why that simply wasn't going to work. So let me show you why that's not going to work. If you look at this, and it kind of makes sense now, because don't do that. Alright, it's fun working around a camera, but anyway. Okay, these are the hot resistance values. 40 watt, 60 watt, and 100 watt are eco bulbs, and so their wattages are different than this, which is an actual 75 watt bulb. Now, if you look at just the 40, 60, and 100, because all 3 of those are the eco bulbs, this is like a 29 watt, a 43 watt, and a 73 watt actual watt draw, supposedly. If you look at these 3, you can see it with all of them, but the pattern is higher, 496 ohms, 342, 209. Now, if you bought a 150 watt eco bulb, its current would probably be somewhere around 130 ohms, maybe as low as 100. And I know that because I actually put all of these in parallel and found out that's probably about what it would be. So as I was trying to figure out what was going on, these are all bulbs in series, hot resistance, and these are the 40, 60, and 100 watt, and you notice I have 1,047 ohms. And I did a variety of different things. I used a large Atwater Kent radio at one point. I used shorted power cord at another point to come up with stuff, and some of it was done with using a separate light bulb to gauge current. So these numbers are going to be all over the lot, probably. And depending on what load you put on the bulbs is going to determine what the actual voltage is that's being supplied, because higher load equals lower voltage, and you actually see that when the radios start up. Initially the voltage that you see on the kilowatt is lower, and then it slowly climbs up as the current declines. So right here on this one, you see I had this was set up with 40 watt, 75 watt, and 100 watt, and I was getting 50 volts and 19 watts out of that one, and about 750 ohms. Then down here in series, I was getting 626 and 23 watts total. Now I don't know why I have that there and then that there, because that doesn't add up to me. But anyway, when I put all the bulbs in parallel, here's that 103 watts, I'm sorry, 103 ohms and 140 watts total. So my mistake was not factoring in the fact that each bulb was designed specifically for the wattage that it was. So that meant that each bulb would have the appropriate resistance to go with the wattage. Now if hey, come on, focus. Stop. There we go. So you take all these bulbs and put them together, you come up with crazy high resistance. However, like I said, if you were to get a 150 watt bulb, the resistance would be a lot lower. And my whole goal is, if I had something that demanded extra current and I still wanted to run through a lamp or lamps, and I actually want it to run, then I really did want that 140 watts. And I can do that by doing it in parallel. I cannot do that by doing it in series, and you can see why. So anyway, that was my screw up, my mistake in my thinking. I learned a few things along the way in doing this. And I want to show you my original schematic when I was doing it in, well, I had the ability to do series and parallel on this. So technically I didn't really need to rewire it, but I decided to just because. I didn't like how I had done it. So let me get the full thing here if I can. There we go. This is how I did it originally. Double pole, double throw switches, a lot more complex wiring. And I tried to figure out how to wire this the way I wanted it to. One night when I was really tired. Don't do that, because I did not succeed. I went to bed frustrated, woke up the next morning, sat down and drew it, and then my mind was clear and I could actually figure that out. But as you can see, this is way overkill and totally unnecessary. Because this was, if you put all the switches this way, it was series. You put them this way, you could get one bulb or more than one bulb in parallel. Now you put them this way, the switch just goes open, and I'll show you that circuit. And you notice that this is the neutral side, and the way I wired this was the neutral side goes to the socket of the lamp socket, and then the hot side, which is this side, goes to, please focus, please, thank you. And then the hot side goes to the center pin. It's probably not necessary in this application, but that's how I would wire it if I were installing a light socket at my house. And so that's what I chose to do here. Either way will work just fine. And if you are swapping out a bulb, I'm sure you're safe if you don't do it the way I did it. But anyway, that's how I did it and why. And I also included this. I have a lighted on-off switch. One of my Radio Shack switches. Now it did come with a circuit diagram, but I, for whatever reason, had trouble figuring it out. I ultimately experimented with it and did figure out how it was internally wired, and then was able to wire it up correctly. So I thought I would include it just in case anybody else has one of those but doesn't have a circuit diagram. It's not real hard to figure out, but this will make it real easy, because all you have to do is follow much easier to follow circuit diagram. And the other thing I want you to see is I put this right here at the very beginning of the circuit, and I made sure the wire was on this side of the outlet, because I wanted to know if I actually had power here, because I typically run this through a isolation transformer. So if I forget that to turn that on, it'd be kind of nice to know, and this will tell me if I have power or if I don't. And it's also, I can tell at a glance whether I've got power and if I've remembered to turn it off or not. So I wired it up this way for that purpose. Now, the other thing that's nice is that when you're working on things, you get distracted. It's nice to be able to just glance at the on-off switch and see by the light that, yeah, there is power there, or no, there isn't, and that it's actually off. And the other thing I should mention is that if you decide you don't even want this, you could take this completely out of the circuit, because if you use these switches correctly, ultimately you can turn everything off this way, because you can see right now I've got it wired with, or drawn with, all the switches open. In this condition, there'd be no power here. It would be dead, completely dead. And so you could use these switches. You could use your bypass switch, bypass switch, as an on-off switch. When the switch is in position, this is open. When it's in bypass position, then this switch closes and it shorts across these bulbs, and that means these bulbs will not turn on. They're out of the circuit, basically. So if you want to make it simpler, and you could also just use 2 bulbs, then you'd have just 3 switches total. Well, you can do whatever you want. Obviously, you can see how simple it is to wire, and you could build your own. Now, I have a little radio set up here, and I wanted to just show you a little bit how this could act as a kind of a variac. So right now you see the voltage is 119 volts. It was just 120. But anyway, so I'm going to turn this radio on. I've selected the 40-watt bulb, and as you can see, it gets really bright at first, then it goes dim, which of course is what you should see when the radio is healthy and everything's working as it ought to. Now, the other thing I forgot to show you, but you'll see that the voltage is changing here. I think it dropped down to about 50 volts when the radio first turned on, and now you see the voltage is climbing up. And that's, of course, because when the radio first starts up, the tube filaments are all cold, they're low resistance, they draw a lot of current, and then as they heat up, the resistance changes, and it goes higher, which reduces the current flow, and then the voltage, of course, here goes up. And now you can see that the radio plays at this voltage, and this is on the 40-watt bulb. With a larger radio with a higher tube count, this 40-watt bulb probably won't work. The voltages will be kind of low. Now, some old radios don't really like to start playing until they hit around, above 85, 90 volts. This little guy is playing now with fairly good volume at this relatively low voltage of 72 volts. This is a 1960s radio, the little GE. It has the miniature tubes in it, the old 5-tube series string set. So anyway, these voltages will be different depending on what you plug into it and what its draw is. Of course, one of the things that you should know is if you plug something in and this goes bright and stays bright, and either this shows really low voltage or it shows you nothing, then you know that that device is shorted, and then you need to turn it off and find out why. Now, there are those who really enjoy letting the magic smoke out, and if you really want to do that, you can just reach up there and hit the bypass switch and let it roar. Let the smoke out. I wouldn't recommend it. You can break a lot of stuff doing that. And that actually brings me to, I'll hit that now. This works great to protect you from shorted devices, or protect the device if it is shorted. It is not, however, a substitute for an isolation transformer. It's handy, and that I am now tending to use this with I'm now tending to use this with my isolation transformer because I like, number one, I've got the protection of the bulb in the circuit. I like the visual indications. It tells me at a glance whether everything's working the way I want it to. And, you know, I have the flexibility of checking things out further, you know, without frying anything. The one thing I should point out is this will not protect the components in the radio. And like right now, this radio is playing. That means it's it's very close to its operational voltage. And if you have bad components in there, say you have a shorted coupling cap or something like that, you can do things like red plate the tube, you can fry resistors. This setup does not protect you from doing that. So this is a good initial test. It's a good way to protect your device. You go in and you replace components, use the bulbs to make sure that you didn't make a mistake and you didn't short something out. The nice thing about this thing is that it gives you other measurements. So right now I've got this on the 75 watt bulbs, so called 75 watt. So if I go up here to the watts, I'm running at 15 watts. Now if I do this, it drops down to 10. If I do this thing wants to move around on me. Now I'm running at around 21 watts. This thing, I think, well, let me put it in bypass. I'll tell you in a minute. Yeah, 28 watts, almost 29. So when you have the ability to mix and match the tubes. So right now I'm at 21 watts. If I add the 75 watt lamp, now I'm up to 25 watts. If I add this one, I'm almost at full wattage, 26. Now, like I said, this will change as well as the, and you can also see the amps here, as well as the voltage here. The load is relatively low, and so the voltage is not as affected by the load. Of course, you do see that when I bypass the tube, or the bulbs, now it gets full voltage, and this voltage isn't going to change because of the load, really, because there's no inline resistance to affect the voltage being supplied. So one of the things I like about having something like this, in addition to the convenience of being able to select what I want, you know, if I want to really protect something and really limit the current going into it, I'll start out with the 40, and then again, depending on how much current it draws, I can just select in other tubes. I can add this one, and now I really boost the voltage. Take that one out. It sort of acts like a variac. You can control the voltage a little bit by swapping in the different bulbs. So I like that flexibility. You probably don't need it. Most of the time you're just wanting to see, is it behaving properly? And what's nice about having the kilowatt is that you can check very quickly the amps and the watts, and if you have a pretty good idea of what that should be drawing, then you can use this to verify that it's operating within the proper range of current. I don't know if these will, some things tell you what their wattage draw is, and some of them don't. This has 30 watts on the back. So if you plug this in and you're reading, you go here and you're reading that it's 35 watts or more, then you have a pretty good idea that something isn't right. And it's time to go looking to see what's drawing the extra current. Having one of these light gadgets to test with, I think, is a good way to avoid damaging something that could start out not healthy. Now, I know people who go through, and I have done this on occasion, go through and they do an initial check. They check the power transformer if it has one. They check the various coils within the radio, all in an effort to, I guess, to determine whether the radio is even worth fixing, or to find out whether or not it has major problems that they have to plan for. I have leaned more toward using this to do a quick test, because if you can get the radio to play, and you can, like I said, with this one I can get it to play at relatively reduced voltage. And you'll notice the volume's fine. So you can get it, if you can get it to play at reduced voltage like this, then number one, you run less risk of damaging components within the radio. But number two, and this is the part that I like, you have a really quick check to see whether or not you have a signal path that is complete. It eliminates the question of, are the IF cans open or not? Is there a working audio transformer? You know, all those things. It's just a really quick check to see, okay, does this radio actually work at all? And, you know, like I said, with the bulbs, if it's shorted, of course you can do a quick check before you even plug it in, turn it on, put a meter across the thing. But sometimes components don't misbehave until you supply power to them. And so you would still want to have something between it and the power, especially if you're turning it on for the first time. So, I mean, there's all kinds of good reasons for at least having something you can plug into with a bulb between it and the outlet. And obviously you don't need to go as crazy as I did. You can probably just take one of these boxes, put an outlet in it, put two bulbs in it, put a switch, a couple switches on the side, 3 switches, whatever, and you get yourself a quick little test box. Simple and easy to make, very cheap. And of course you'd have to have you wouldn't need any of this part. You could build it all on this. Or you could get one of these and tie it to this. You know, the options are limited only by your imagination, I guess. So I thought I would share this, and if anybody finds it useful, it'd be great to know that. If you think it's overkill, which it probably is, you can say that. One of the things I really like, and I've actually used just recently, is having this on-off switch right here is very handy. I said, even apart from the fact that the light in it tells me whether I've got power or not. I had a radio in here that I was working with, and the on-off switch was very sketchy. So, even though I had gotten the switch working again, because it actually stopped working on me, I decided that I didn't really want to test that switch any further. So, since I had it plugged into this, I started using this as the on-off switch when I was working on it. And that was convenient, because all I had to do was reach across here and get it. And I have an on-off switch on my transformer up there. But this was right here, and I can just reach over and tap it, do whatever I want to do, then turn it back on. So there's a convenience factor with this, which was the other reason why I built this. I wanted to have flexibility, I wanted to have convenience, and I thought it would be useful, and I actually have started using it more than I thought it would. Once I got the isolation transformer, which is also a variable transformer. In fact, my device is this right here. It's the Sencor PowerRite. It's a PR57. It's a handy little device, very useful. I use it a lot. And so if you use that in conjunction with this, then you can set whatever voltage you want to set on initial startup, and you can protect your radio even further while still having this in circuit. So anyway, I hope you found this interesting. I hope somebody gets something out of it, and I really do appreciate it. If you've watched this far, I appreciate you hanging around, and hopefully I'll see you next time on my next video. Thank you.